So, welcome back to the shop. Last time you saw me hardening these parts for the UniMike, and I had them bead blasted, so the black scaling from the oil is gone, and I also had them checked for hardness. When you remember, I was shooting for 55 Rockwell C, and I had it checked on a proper Volpert hardness tester, Rockwell hardness tester, and checked it in 2 spots, and we came each time to 54 Rockwell C. So we were pretty good in the zone of hardness we wanted. I also ordered a set of hardness testing files that Tom Lipton showed in one of his videos, and because I don't have place for a proper hardness C tester, and I don't like these the hardness testers with the automatic spring punch. When I bead blasted them, I cleaned out the holes with an old reamer, and I already ground the clamp for which holds the exchangeable anvil. And when I cleaned out this deep 5mm reamed hole, I realized that it hadn't changed size at all. When I take a 5mm dowel pin, it's a nice sliding fit. It's a bit looser than it was before because I ran some emery cloth through it to clean out the grit, but that's a pretty good fit, pretty tight fit. I like it. And I ground the anvil off camera because the clamp for the anvil off camera because there is not much to it, just squaring it up and grinding the slot here. And just for testing purposes, I pressed in a 5mm dowel pin. And when we get these two parts together, it already fits quite nice. And as you might remember, oh no, I didn't show this. I also drilled two 2mm holes here, and I drilled and reamed two 2mm holes in this part for additional dowel pins, so this part cannot rotate. The pins will be pressed into this clamp, and the pins will engage these two holes, so there will be no rotation possible. One would be enough, but for some reason I can't remember why I did two, so we're going for two. And I still need to grind a V-groove into this part, so we can also hold a dowel pin as a gauge pin to measure hole distances and stuff like that, or wall thickness of pipes. And you can also clamp in a normal 9mm wide gauge block like this. So now we're going to grind this part. We will start top surface, bottom surface. Those two surfaces are the important surfaces. Only those two. In fact, only this surface and the bore are really critical, but I need this surface to do the other surfaces after that. So we will start out, we will set it up on the magnet, grind this side, flip it around, block it in so it doesn't fly off the magnet because the lower surface is pretty small. Grind the top surface, and then before we and then we will grind the thickness here. When we have done that, we will grind the bore on the lathe, so our drum can go in there. Somebody asked me how I'm going to fix the drum into this body. That's easy. The plan was first to clamp it with, to have this part slit and have a clamping screw at an angle, but I was worried that the slitted part might warp like crazy when I harden it, so I opted for Loctite 648 bearing glue. So we're going to align it and then we're going to glue it in. If we ever have to exchange this drum or barrel, we can heat it up to 150 degrees C without disturbing this part, pull it out and set up a new one. So let's go to the surface grinder. Okay, grind the first side, and as you can see, I already touched off on the part. I know a lot of people don't like this practice, but for me, until I'm more experienced on a surface grinder, this is a very safe way to touch off. Okay, I took off 3/100 of a millimeter just to clean up the bottom surface and leave a good, nice finish. I was also feeding on the finishing cut very slow, so get a nice finish. And I got a new toy. This is a readout for the digital indicator that I have on my down feed of the surface grinder, and this is made by Daniel Salros, and he sent it to me to test it, and so far I like it very much. I will do a proper segment on this readout when I tested it a bit more. Okay, I flipped the part around, set the freshly ground surface up on a magnet, and I blocked the part. And I blocked the part in, and as you can see, the holding power on this small surface and with such a tall part is not very high, so we're going to add some clampiness to make it a bit more rigid, and we're just going to use one of these parallel clamps and lock it to the side of this block, just so we have a bit more grip. We're not going to take a deep cut anyway. Okay, I clamped the part laying down flat in the vise, and I aligned it with an indicator so it's flat in that direction too, or parallel to this to the base. Okay, you saw me first taking very heavy cuts of 5/100 of a millimeter depth, and then I took a finish cut at 1/100 of a millimeter. If I had magnetic parallels, I just cut up the second side now on the magnet, but as I don't have magnetic parallel or magnetic transfer blocks, I have to set up the second side also in the magnet. I had it on the surface plate, I had a stack of gauge blocks in here, and I set up everything nice and square, and now I can grind the second side. Okay, right now I'm grinding the ID for the micrometer barrel, so we can slip it in and secure it in place with some Loctite. I have set up the part on the magnetic chuck with 2 blocks to give it some support, and over here I have my diamond dresser, so I don't have to set up the diamond dresser every time. I can just bring over my grinding spindle like this and press the grinding stone with the spindle of the lathe stopped, of course. Only having the tool post grinder running. And I will tell you something about ID grinding. 0.6 millimeters of grinding allowance is way too much. It really gets odd. Next time I will go with 0.2, maybe even yeah, 0.2 or 0.15 would be absolutely enough to clean up this hole and bring it to size. I wish I had higher RPMs. This calls, normally you would grind something like this at about 30 to 40,000 RPMs, and I have maybe 10. So this is absolutely not ideal. But we get pretty good finish anyway, and I hope that it gets cylindrical too. The stone is very fine. I wish I had a rougher stone, a 36 or 48 grit that doesn't load up that fast. This one is about 80 grit and it loads up super fast. Without some cutting oil it doesn't work at all. With the cutting oil it's working pretty good. Maybe I will get it done one day. So let's check our diameter. I'm still in the range of measuring with calipers, not with the UniMike. Okay, we are at 9.8 millimeters, and we need 10, so we have 0.2 millimeters to go. That's about half an hour of grinding. Let's dress the grinding stone. Okay, I'm giving it a pretty rough dressing, so it cuts a bit more freely. Now we go over to our bore, set it in the right spot, add some cutting oil, start up the spindle of the lathe, and tool post grinder. Now we touch off. And we grind. Okay, after some fiddling, I got it done. I had to change the stone for a mounted cubic boric nitride grinding tool, ID grinding tool, and these cut more freely, and you don't need to dress them, of course, because it's cubic boric nitride grit that has been bound to the metal carrier or metal base, and they leave a bit rougher surface finish, but as said, they don't need dressing and they cut more freely and they don't glaze up that easy. We'll take our mic barrel now. You can see that this is a pretty tight, close fit. And that's what we wanted. Now we can tear down the setup from the lathe, clean the lathe because it's a mess of grinding dust. Okay, we're back at the grinder and I want to clean up that radius. I have my grinding vise on the magnet, and I have a piece of a 10mm ejector pin which is hardened, clamped in the vise. Everything is aligned, and I will slip the part with the ground bore over the ejector pin, which is a very close fit, like this. And then we can swing the part like this and grind, and then we can grind along the axis. Okay, I touched off on the surface. I will dial in 0.15 millimeters and give it a shot. As you can see, we have unmachined areas left here, and I will blue up the surface so I can see the progress we're making. I will dial in another 0.15 millimeters, and we're good to go. Okay, I ground the complete radius. As you can see, came out quite good. This is just a cosmetic radius. Okay, as you can see from the grinding, we have a lot of small facets, and right now we're blending them into each other by stoning. So it's a nice uniform radius. I'm using a small triangular or flat stone soaked in some WD-40, so it's cutting more freely, and just working along. And I do it just like I would file a radius. I'm following the radius like this. And as you can see, the blend from the radius into the flat portion here, which we will grind later, is not straight, and that's because the part warped slightly during hardening. That looks quite okay for a for a cosmetic radius. I will hit it with some 400 grit emery cloth, and I also soak in some WD-40. And with the, you know that I rolled the stone off the surface when I worked the radius. That's how you create a true radius by filing. And now with the emery cloth, where I just cleaned the surface, I follow the surface like this. Okay, looks perfectly fine to me. I like it. So now we grind these two outer surfaces, and we will grind those slightly behind the radius, so we don't get a perfect blend, but the radius runs out over the surface. Okay, we're over at the bench, and as you can see, I finished all the grinding on the body of the UniMike, and I also finished the clamp, which holds the exchangeable anvil in place. I need to reduce the diameter of the pins by maybe 1/10 of a millimeter or something like that, so everything will slip together nicely, nice and easy. And I need to make the drawbar that pulls the clamp against the body. But already we can see we can take a gauge block, clamp it with the clamp, and we have our micrometer barrel, and this slips in here, and now it looks very much like a UniMike. By the proportion, it works very well. I can hold it with one hand and do measurements like this, and yeah, I'm very don't know what else to say. I'm very happy how this came out. The radius in front here looks very nice. I'm happy that the heat treating worked out that well, and that the grinding also worked that well. The ID grinding and the surface grinding. I still have a few issues with surface finish, but okay. I made the parts of camera that go with the clamp. I made the drawbar and the brass knurled nut, and I already Loctited it in the drawbar into the clamp, and I reduced the two guiding pins to about 1.9mm diameter, and now it slips together very nicely. It has some side play, but that doesn't matter, doesn't mean anything. And I milled a small V into the jaw. I hard milled the V into it. So, and the reason for the notch is, of course, so you can use a pin as an exchangeable anvil when you measure hole distance to an edge, or you want to measure wall thickness of tubing or stuff like that. And the brass knob goes on this side. I did some engraving. I used a 0.8mm ball end mill and took a 0.1mm deep engraving, used some black Sharpie, and then I wiped off the remaining black with some writing paper. The paper acts like a very mild abrasive and cleans off the excess paint. Some people use a rag that's soaked in solvent, but that most of the time doesn't work very good because you wash out the paint from the engraving too. So I use a dry, no solvent, no nothing, piece of paper, and just rub off the excess color. And now we need, last step is to mount the micrometer barrel into the body here. Then we're done. And for that purpose we will take, first we will take it apart again. And we clean the bottom surface on a piece of paper. And we take a gauge block that we also clean on a piece of paper. And this is a used gauge block, so I don't mind stoning it. I use one of these superfine ruby stones, so I won't change dimension at all. Now as this surface is clean, we can use this as a reference, and we will use it as a reference by design. So we'll clamp the gauge block in here. Lock it in place, so just very lightly snug up the knob. And now we will take our micrometer barrel, screw it down to 0. Make sure that the face of the carbide face here is clean too. And then we will put it together with some Loctite, without the gap here, and with this set to 0. And then we have our and then it's calibrated, or rough calibrated. The fine calibration can be of course done via a small spanner and rotating the drum, but the general setup comes now when we lock the drum in place. So let's take it out. Let's take some acetone, clean the micrometer. And I really have a problem pronouncing micrometer. Micrometer. Ah. Amber will also clean the bore from the inside, so the Loctite has a fighting chance. Okay. Now we get our Loctite. And of course we must make sure we must make sure that we don't glue our drum here shut, or the measuring spindle. That would be a bummer. What I'm going to do is I'm going to put some Loctite onto this diameter here. Then I'm going to push it into the body of the micrometer. Just align it. Oh yeah, this is going to be, this will be a special one. We don't need much Loctite, just small, that'll do ya. Okay. Unfortunately, this drum has no lock, so we have to be very, very careful. Clean the face. This one's clean too. And shove it in. There we go. Now we wait until the Loctite has set. And then we're good to go. Okay, I will just rest it here on the workbench and you can watch Loctite curing. I'll be back. Okay, the Loctite has set and now I have a fully functional UniMike, Shopmade. And as you can see, I already calibrated the barrel to 0. And what I want to check now is if the spindle here is truly perpendicular to the anvil. And you can check that with a ball bearing ball. You just measure the thickness or the diameter of the ball in different locations, and the micrometer needs to show the same measurement in every position. I can show it to you with my good digital mic. This is a 6.35mm ball. Six point three five, 6.35, 6.35, 6.35. And that way you can check the face of the micrometer. And to clean the anvils you can take again a piece of paper and wipe the faces of the measuring surfaces, because I had the feeling that there is some gunk in it when I checked it. Six point 352, 6.35, 6.35, 6.35, 6.351. Yeah, of course you have also to take into consideration that you exert pressure on the ball in only one spot in a very small area, and that will also deform the ball. All that stuff comes into consideration when you check stuff with that close tolerances. But this is only reading 1/100 of a millimeter, so we will be perfectly fine with this check. And we start here at 3.5, go over, we read 3.5, dead nuts on, 3.5, 3.5 slightly under, so that's pretty good. Now I have a 10mm gauge block here that when we check it with the Mitutoyo, with the digital one, should be pretty much 10mm. Might be time to check our zero on this mic. Haha! -2. 0. Oh no, origin, that's it. Okay, let's check the gauge block again. That were only 0.002 of a millimeter off, but that's okay. 9.9999, and over here we have 10 dead nuts on. And really, measuring to 1/1000 of a millimeter is tricky. You get in the area where everything counts. When I hold this this mic for a long time in the hands, it will grow slightly, and then it will get a misreading. And now we check our Shopmade mic. I have 10 over here, and we have 10 down here. So looking quite good. I'm very happy. And now let's take out this anvil, or this this gauge block, and take a 5mm dowel pin. Okay, that's perfectly fine. We get with the dowel pin also a 0. Okay, and in case you wonder what the mic is used for, you can measure, for example, the distance of a snap ring groove to the end of a workpiece. Like this. And by using different thicknesses of gauge block as an anvil, you can reach into very thin grooves. Another tool that you can use for that purpose is of course the disc mic, but the disc mic can only go in about 4mm deep, and with this mic I can go in about 16mm, reach in. And of course another use is with a gauge pin, or dowel pin in my case. To measure the distance of a hole to the edge of a workpiece, like this. Of course you would use a matching gauge pin to the hole. Then you can measure the distance minus the radius of the hole. With the pin you can also measure the wall thickness of pipes very accurately, like this. and this has a wall thickness of 1.02 millimeters. And some dirt in it. So yeah, and that way you can, as I said, oh, this is quite a bit bent. The UniMike is quite a handy tool, and you can get them often used on eBay, but in Germany they are quite uncommon, so I made my own. I hope there was something interesting for you in this video, for all of you, and oh, by the way, I reached 10,000 subscribers quite some time ago, and I want to say thank you to all of you again, because I don't take it for granted that you take your time, spend your time, and watch my videos of some guy in a shop fiddling around with stuff. And I get so many great comments, very nice comments, and also emails. Thank you all for watching and subscribing and commenting. It's just great. So see you next time.